Good morning. Welcome to Mission Control Houston, the home of the International Space Station's Flight Control Team. From these consoles, specialists are at work around the clock to keep a close eye on the operation of all of the systems on the vehicle and to coordinate the activities of control centers operated by station partner space agencies all around the world in support of the ongoing mission. This week, Commander Anton Shkaplerov and his Expedition 55 crewmates have been busy with a variety of science activities, including one utilizing a Japanese levitation furnace, while getting everything in order for the second spacewalk of the mission, which comes up in just a few days.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Isidro Reyna. This week on station, the crew prepared for an upcoming spacewalk. 2 NASA astronauts are scheduled to venture outside the International Space Station for a 6.5-hour spacewalk on May 16th. Expedition 55 flight engineers Drew Feustel and Ricky Arnold have been prepping their spacesuits and reviewing procedures this week for what will be the 210th spacewalk in support of space station assembly, maintenance, and upgrades. The primary objective is to finish upgrading cooling system hardware. Live coverage of the spacewalks will air on NASA TV and nasa.gov. This week, the crew worked on the electrostatic levitation furnace, also known as ELF. ELF is an experimental facility designed to levitate, melt, and solidify materials by containerless processing techniques using the electrostatic levitation method. With this facility, thermophysical properties of high-temperature melts can be measured and solidification from deeply undercooled melts can be achieved. The crew exchanged the sample holders and installed a new sample cartridge within ELF to prepare for upcoming ground-commanded operations. Students from Houston area schools spoke to astronauts on the station during an event hosted by Boeing and Space Center Houston. The event was part of NASA's Year of Education on Station. Scott Tingle was asked about the science being conducted on board the ISS.
We have at any given time 200 to 250 experiments that are being worked on the International Space Station. But some of the big ones that I've been working on include Apex and Veggie, and they include growing vegetables. We grew lettuce. We're looking at combustion, and we're looking at capillary fluids flow, and we're taking part in a lot of human research, such as what happens with our blood, what happens with headaches and fluid shift, and what happens with our bone density, and things like that. So lots of stuff going on here, and it's an amazing place to be.
This week's Twitter question comes from Ozzy. He wants to know how astronauts keep track of where they are in space. The station's position, or state in space, is determined by a global positioning system, or GPS receiver, similar to those in a car or mobile phone. The receiver keeps track of the space station's position and velocity at all points in orbit. Flight controllers in Houston keep track of how the station is oriented and where the sun, Earth, and communication satellites are in reference to the station. Keep sending in your questions using the hashtag #SpaceToGround. We'll see you next week.
NASA TV and nasa.gov will have live coverage of next week's spacewalk. It begins at 5:30 Central Time on Wednesday morning, May 16th. Spacewalkers Drew Feustel and Ricky Arnold are expected to be ready to open the hatch and start work outside the International Space Station about 7:10 a.m. Isidro mentioned flight engineers Scott Tingle's and Drew Feustel's question and answer session with students gathered at Space Center Houston this week. That's part of the ongoing Year of Education on Station, which also features the crew members using some of their time to shoot videos explaining scientific principles and important topics related to human space exploration. This week, Tingle released the latest demonstration video, in which he shows the importance of nutrition for men and women who are of this planet, if not on it at the moment.
Hello, and welcome to the International Space Station. My name is Scott Tingle. Here on the space station, we live in a microgravity environment, which makes eating here a very unique experience. To stay healthy, we have to maintain a nutritious diet, just like we would back on Earth. Let's go take a look at some of our food and drinks and check out our meal preparation area. During long-duration spaceflight, we have to make sure that we receive enough energy, proteins, and vitamins. Our food lab back on Earth makes sure we get plenty of each as they carefully prepare, test, and package everything. We combine all of this excellent nutrition with exercise to ensure our bodies stay healthy and strong while we're here. We eat 3 square meals a day, just like we do on Earth, maybe throw in a snack or two. One of my most favorite foods to eat are natural raisins. Here on Space Station, we have to keep our calories up if we want to get all our work done. And the carbohydrates in these raisins really help. And they're kind of fun to eat, too. And how do we stay hydrated in microgravity? With these special pouches. They're filled with water, and we use a straw that has a one-way valve that prevents water from floating out of the pouch while we're not drinking from it. Here's a liquid drink. This is a tropical punch for today. I love drinking fluids on station. Here on station, we have a pretty cool food preparation area. We have a place to get fresh water for us to drink or to put in our rehydratable foods. And we also have an oven to put food in. We pick out some of our favorite foods, chicken fajita for me, put it in the oven, close the door, and turn it on. In about 15 minutes, I'm gonna have a warm meal. Thanks for exploring a little nutrition with me. I'm gonna send you back to Earth so you can create your very own astronaut menus. See you again soon.
Learning about proper nutrition for space explorers is one aspect of learning how this microgravity environment impacts the human body. And it's all part of the human life sciences research underway on the International Space Station. So is research into the functioning of the human immune system in space. And there's a new experiment underway on board to learn more about how that critical system will be affected during a future mission out into the solar system.
Your immune system in space. Presented by Science at NASA. Getting sick when you're far from home is a drag. You'd give anything to crawl into your own soft bed and sleep, but you're stuck in a cookie-cutter hotel room feeling like a sick fish out of water. Well, it could be worse. You could be an astronaut on the way to Mars, a really long way from Mom's chicken soup. Future space travelers will need to stay healthy to perform well for their own safety and for mission success. So it's important to understand how extended space travel will affect them. The immune system works unnoticed to protect the body. But even subtle changes in that all-important system may be linked to the onset of illness. Factors like radiation, microgravity, stress, and altered sleep cycles could all affect astronaut immune systems. A new NASA study entitled Functional Immune will investigate the immune system changes that occur in International Space Station, or ISS, crew members. Understanding these immune system changes may help scientists pinpoint the onset of illness and suggest monitoring strategies or treatments that can boost the immune system and prevent full-blown infections and diseases here on Earth. Functional Immune builds upon the results of several previous NASA studies of the immune system, which, according to Johns Hopkins University scientist Dr. Mark Shellhammer, tell us there is no place during spaceflight where we see stabilization of the immune system. In 2014, NASA's Integrated Immune Study showed abnormalities can occur in immune cells in ISS crew members' blood during flight. Normally, the immune system attacks and eliminates virus-infected cells. When cell activity is depressed, the immune system isn't responding to threats as it should. When cell activity heightens, the immune system reacts excessively, which can result in illness, increased allergy symptoms, and persistent rashes. ISS crews were also observed to experience reactivation of latent viruses from childhood, a finding directly related to reduced immune function. The Integrated Immune Team, working with the NASA Nutrition Laboratory, also measured the concentration of cytokines in blood plasma, the proteins that marshal the forces to an infected or injured body site to defend against invaders. The data indicated that changes can be seen in blood cytokines just as changes can be seen in cell function. Dr. Brian Cruchon of NASA's Johnson Space Center, or JSC, principal investigator of the Functional Immune Study, says, "The immune system is very complex, and several aspects of immunity remain uninvestigated during spaceflight. We now need to delve deeper into the immune system changes that happen in space, and also determine if immune changes during flight elevate clinical risks for astronauts in future deep space missions. All the factors that change immunity on the ISS will be worse on longer missions to an asteroid or to Mars." Functional Immune includes NASA scientists and external collaborators at the Johnson Space Center Radiation Lab, the University of Houston, and the State University of New York. The study will reach beyond any previous space immune study and include exciting newer tests such as transcriptomics and proteomics. These tests will happen in parallel with the assessment of immune cells in blood, stress, and virus reactivation. Cruchon says with the ISS, we have a unique opportunity to study very healthy people in a quasi-isolation chamber, yet experiencing all the stressors that are specific to spaceflight. Results should help clarify the influence of spaceflight-specific environmental factors on immunity and identify countermeasures to mitigate their effects. These studies could improve scientists' understanding of the immune system, making a positive impact on human health at home and while traveling both near and far. For more from the International Space Station, go to www.nasa.gov/station. For more news about spaceflight and the strange things it does to the human body, visit science.nasa.gov.
Human beings are not the only living things being studied by scientists using the International Space Station. There is a new piece of hardware, the multi-use variable gravity platform, that's designed for research with many organisms and cell types. Its first research is focused on fruit flies.
We're looking to answer the question, what is the effect of spaceflight on the host here being the fruit fly or Drosophila, and also on a pathogen. So the bacteria actually is one that can infect the fly very similarly to the way it would infect, for example, a human or any other organism. The genetic makeup of the fruit fly is actually very similar to humans. If you took the human genome and you looked at all the genes that you know are important for function, in that category, in that library of genes, there's 75% similarity between the human genes and the fruit fly genes. In a box this size, thousands of flies can be flown and brought back, so that even if you see an important difference that is small, you can get statistically significant data because you get 3,000 flies or 4,000 flies coming back in a box that size. We have a very nice new piece of hardware. The company TechShot, we've been working together with them for the last few years in developing a very capable piece of hardware.
What's so special about the TechShot MVP is really that there are two internal carousels inside the unit, and each one of them can produce anywhere from 0 to 2 Gs. So it'll be the only payload of its kind in the US segment that can do this. The sample modules themselves do transport to and from the station in the cargo vehicles, but the payload itself, the locker, stays on board the station permanently.
We are interested in human exploration. We want to go to Moon, we want to go to Mars, we want to explore the environment outside of low Earth orbit. And to do that, we need the help of these surrogate model organisms, because once we understand the genes and the pathways, then we know what the countermeasures are that we're working towards.
Being being able to identify microbes aboard the International Space Station in real time would be revolutionary for the world of microbiology and space exploration. Well, the Genes in Space 3 team turned that possibility into a reality last year when it completed the first ever sample-to-sequence process entirely on orbit. This advance could aid in the ability to diagnose and treat astronaut ailments in real time, could benefit other experiments aboard the orbiting laboratory, as well as assist in the identification of DNA-based life on other planets.
So then we kind of went for the home run experiment, which is actually trying to get a sample that originated on the ISS.
And the goal was really to show that you could go all the way from a sample to an answer all on board.
I am going to do this really neat experiment today. Last week we took some surface samples, microbial surface samples. There will be enough DNA after we magnify it to sequence it. And then from that sequence, then we can determine what type of bacteria it is. So it's going to be really exciting for us, I think, to try and do this for the first time all on board the space station.
In that moment, she's in the microgravity science glove box as she's collecting those cells. My heart was just pounding because what she did had never been done.
Our DNA cake is in the PCR oven. We'll look forward to getting lots and lots of DNA from each of those 3 little bacteria colonies.
They're like, we can just patch your cell phone in to the space to ground loops and you can just talk to Peggy on your cell phone to do this. There's a hurricane raging literally outside, but the folks in Marshall, they're on it. They're gonna make this happen. Science on station is not stopping because of Hurricane Harvey. And right away, we saw one microorganism pop up and then a second one. I thought, oh my gosh, I am watching the first sequences ever of an unknown from space.
I checked several times. Like I ran like a biochemical test and then I ran 2 different sequencing tests. We are 100% sure that our samples that we got back on the ground are exactly the same that we got on orbit. We did it, everything worked perfectly.
As a microbiologist, my goal is really to that when we go and we move beyond ISS and we're headed towards Mars or the moon or wherever we're headed to, we have a process that the crew can have that great understanding of the environment based on molecular technology.
Would you like to go to the International Space Station and check out all those experiments? Of course you would. But when you can't go to the space station, sometimes the essence of the space station can come to you. Starting May 15th, Destination Station arrives in Salt Lake City, Utah to share the impacts of the station on our daily lives. Here's a peek at some of the ways you could learn more about what the International Space Station is doing right now.
Destination Station is a national campaign where NASA and the Center for the Advancement of Science and Space, also known as CASIS, partner together to share the impacts of the International Space Station on our everyday lives. Through general public events, meetings with researchers, educational activities, and legislative discussions, NASA astronauts and scientists work with CASIS to discuss the benefits of flying research aboard the U.S. National Laboratory. The space station utilizes microgravity, extreme conditions, and low Earth orbit to provide a unique science platform, which has currently enabled over 2,400 researchers in 95 countries to conduct more than 2,000 innovative experiments. Since 2000, the station has supported investigations in the areas of biology and biotechnology, human health, technology demonstrations, and Earth, space, and physical science. Through communicating the benefits of today, as well as the opportunities of tomorrow, Destination Station highlights how the International Space Station is working off the Earth for the Earth.
No one knows the International Space Station better than the people who live and work there, and they often take some time to show off their home on orbit. During Expedition 52, the crew produced a series of bite-sized explanations of station components, which they called Speedy Time for reasons that will become clear in a moment. Here, flight engineer Jack Fisher gives us a quick but thorough tour of payload activities, both inside and outside the airlock in the station's Japanese laboratory module, Kibo.
Hi everybody. I'm going to do my best over the next few months to show you in bite-sized chunks this wonderful place I get to call home. I'm going to have to talk fast, so we're going to call it Speedy Time. All right, the first one is the gym airlock. This is so cool. It has a slide table. We open it up, the slide table comes out, we can put all sorts of things on it, put it back in, depressurize it because it's an airlock, and then slide it outside. We have a robotic arm. We can control it with this wonderful panel here, or they can control it from the ground. How cool. And then once it's outside, we put all sorts of experiments out there. Let's take a look because it's gorgeous. This is the gym window. Woo! And there are some of the experiments, including the robotic arm, which then controls all of those experiments once they're outside and puts them in the right position. Or, in the case of small satellites, it actually launches them. How cool is that? That is your first Speedy Time video. Have a great day. See you next time.
Flight engineer Scott Tingle is about 3 weeks away from completing his first space flight, adding that to a list of career achievements that already included bachelor's and master's degrees in mechanical engineering and time in private industry, a naval aviator's wings with multiple overseas deployments, and experience as a test pilot. All of that before he joined NASA. He was also in a rock band, and even that has a relationship to his training for this mission to the International Space Station.
Okay, marker.
I was about 15 years old when I started playing guitar, and I started learning. I took lessons from my neighbor up the street. I got really good at it, and I really liked it. I was used to working with tools and doing math and things like that. And the guitar was just, it provided all of the things that I think I was lacking at the time. And what I love about it most is the fact that it can be loud, it can be a lot of stress relief, or it can be soft, it can be however you are feeling at the moment. It's a great projection of emotion. Well, when we first started, I was 16, 17 years old, and I met a few folks that had the same interests, and they asked me to join their band, which I did. And we started off playing a bunch of high schools, Battle of the Bands. We won a few of them. We wrote a lot of original music. And then as I got older and I was in college, we started to play a couple of colleges and more clubs in Boston, Kenmore Square area, as well as in Providence, Rhode Island. Actually, one of the songs that we had put together and recorded made it into the Boston Top 10 on a local album. Yeah, so team skills, very important in a rock band and in any kind of team effort. And, you know, there were times where the writers and the band wanted to go in a certain direction. There were different times the drummer wanted to go a different direction. There were times where I wanted to go in a different direction. And at the end of the day, we had to have a direction so that whatever we were doing would sound good. Some of these same skills I learned by being in a band, I still use today. You've got to have all those skills. You've got to be patient. You've got to be able to see the value in the other ideas that people offer and allow those to take a full fruition and come to make the program whole. I'm Scott Tingle, and I'm a NASA astronaut.
NASA's Johnson Space Center is the center of activity leading the design and build-up for a critical safety test for America's new exploration spacecraft. An Orion crew module was delivered to Houston in March for assembly and outfitting for the April 2019 Ascent Abort 2 test. That'll demonstrate the ability of the spacecraft's launch abort system to pull the crew module to safety if an emergency ever arises during ascent to space. Doing this work at JSC is part of a lean approach to development to minimize cost and schedule risks associated with the test. If you'd like to get another look at any of the stories we featured today, check us out on YouTube and on Facebook. You will be able to look at these stories and a lot of other great stuff about NASA and America's human spaceflight program. If you're interested in good conversation about space exploration, check out Houston, We Have a Podcast, which features folks here at NASA talking about their work, their personal experiences on the job. New episodes post on Fridays. Today, May 11th, my colleague Gary Jordan talks with Jeff Fox about the work of NASA's Rapid Prototyping Laboratory and the development of the crew displays for the Orion spacecraft. Go to www.nasa.gov/Johnson/HWHAP. As Houston, We Have a Podcast. You'll find all the episodes right there. You can also listen on iTunes, Google Play, and SoundCloud. And be sure to join us this coming Wednesday morning, May 16th, 5:30 a.m. Houston time, for live coverage of Drew Feustel and Ricky Arnold on their second spacewalk of Expedition 55. This is Mission Control, Houston.